Hello, my name is Sahil Kirangi, and this is the Physics 2211 Lab 4 on oscillations. So the introduction for the lab. So the purpose of this lab was to analyze the observed motion of a spring mass system in the x and y directions in terms of oscillating motion. We used this for the video analysis section. Then we created a computational model via GlowScript to model the oscillation and compare it to the observed position of mass. I used Tracker for the observed position of mass and GlowScript for the computational model. Tracker we use specifically on the video analysis section for the observed position of mass, yeah. Then the total results was we determined that the system does not follow the energy, we determined that the system does follow the energy principle, as while the other energy systems do fluctuate, the total energy does remain at 0. So the fundamental principles we used Newton's second law, which is used to describe that a system's change in momentum is equivalent to the net force that is applied. Next, I also used the energy principle, which described that a system's change in energy is equal to the work done by the external forces and thermal energy exchanged with the surroundings. And then we also used other equations that we've looked at before, like the velocity update formula, position update formula, as an example. So this is our actual observed motion. So I specifically chose the video analysis section, and on the right you see the video analysis on Tracker, and then the left is the Tracker data. Now this is our code used before we start the calculation loop. This is in GlowScript, and these describe the initial conditions, which include the position and velocity vector and the ball mass. And then they also describe the gravitational force and then the spring constant and relaxed length of the spring that we match with our video. Now for the calculation loop, up here first on the top right, we have the actual calculation for L, L hat, and S, and then we calculate the different energies. So K, gravitational energy, spring potential energy, and then the total energy. And then on the bottom, on the bottom left, we have the actual calculation loop. And so in the calculation loop, we have the position and velocity update formulas, we have the spring update code, and then we calculate the change in energy in the system down here. The actual change in energy, yeah. So in terms of the observed and computational model relationship, this is the basic results of our computational code. So they depict the x to y position in relation to time. This is what our graphs show. They show they're relatively the same, relatively similar with our computational model. And then same with the actual results of the spring. So we could see that our model is similar to our observed experience. Possible sources of error that we had. So basically, because the system is not completely isolated from its surroundings, there will be work done from the surroundings that is left unaccounted for, and that could alter our findings. And then also there's just human and clerical error, so inaccurate placement of the trackers for video analysis in terms of the tracker application, and not tracking the overall center of mass in the video properly. That will just end up skewing your results and giving you altered results compared to the actual model on GlowScript. So what does this mean? Looking back, is the energy principle actually satisfied? So looking back to our results, the energy principle is satisfied because there is no external force in the system. As a result, the change in energy must be 0. So as you see here, delta K, delta U gravity, delta U spring potential, all that, everything is fluctuating, yet the actual total energy remains 0. So therefore, the energy principle is satisfied. Now our periods of x and y, so we calculated the